Hello, this is Captain. Welcome back to Stormworks Basics. This is going to be a new tutorial for modular engines. So I like to put these out every once in a while as things change, as things get refined or find better ways to do things. And this keeps everybody a little bit updated in case there's any changes to the game that this will work. And I'm going to make our modular engine really quickly. So I'm going to type in mod for modular, and we'll go here. We're just going to make a one by one. So going through the parts again. We have an air manifold that controls the air going into the cylinders. We have modular engine alternator that produces electricity, a little generator. We have a clutch, sizes 1 by 1, 3 by 3, 5 by 5 for the three different engine sizes. We have a modular engine coolant manifold for cooling. Crankshafts 1 by 1, 3 by 1, 3 by 3, 5 by 5. There's a converter to convert a 3 to a 1. This converts a 5 to a 3. We have our three cylinder size, 1 by 1, 3 by 3, 5 by 5. We have our belt drive for 1 by 1, 3 by 3, and 5 by 5. We have two exhaust manifolds. We have a corner piece and a straight piece. We have a belt-driven pump, which will go off these belt drives. We also have three flywheels, a 1 by 1, 3 by 3, and a 5 by 5. We now have the fuel manifold. This controls the fuel going into the cylinders. We need to balance fuel and air in order to get proper stoichiometry to make the engine run. We have three manifold pieces. We have corner, straight, and T. We also have a starter, which we require to start the engine. This piece right here isn't all that useful. Modular engine temperature sensor. We can use the composite node for this, and I find that to be much better. All right, so we're going to go ahead, and the first part we'll work with is a crankshaft. So what is a crankshaft? IRL, a crankshaft turns the up and down motion of a piston. The piston will go up and down, and it will turn it into a rotary force, which then allows us to turn wheels, propellers, whatever we might be doing. So we're going to make it a car in this. So the next thing I want to add here is a 1 by 1 belt drive. The 1 by 1 has to go with the 1 by 1. Pretty simple there. I'm just going to select this really quickly, and we'll move it up, and I'll put it on a pedestal. All right, so this is now just up, and this will give us access to all four sides. We need to look at these pieces. So we have a bunch of shapes here. The shapes go to like shapes. So right here on the back of the crankshaft here, you'll notice we have this octagon here with a larger one. This is simulating the crankshaft, which is literally a shaft of metal that goes through that allows each piston to attach to it. You know, if you have a one cylinder, it would be like this. You had a second cylinder, that shaft would then transfer the power of both cylinders. We also have these squares here with these little diamonds. Those are where your pistons are going to attach. You can put your pistons all the way around or as few faces as you'd like. We also have these rectangles. This is what's going to connect for your belt drives. You need to make sure that the belts of the belt-driven components go over this pulley. That's how they work IRL. That's how they work in game. So if we type in mod for modular, we have a starter. That has a belt drive on it. So you want to make sure these are oriented correctly. As you notice, it's facing forward. You can see the belt when we go to put it on there. So the way this would work IRL is as the crankshaft turns, it would turn this pulley here, and then it would turn the belt and turn the pulley on top. Now with the starter, it's going backwards. This pulley is turning to start the engine. In order for us to start the engine, we need to get up over 2 RPS. So, you know, you want to be careful about making sure the parts are on the correct face. So if I turn that, you'll notice we have the rectangle and 4 diamonds. It has to go to a rectangle, 4 diamonds. We can't try to connect it like this. You know, that will stick there, but you notice that is not a rectangle of 4 diamonds. It will do nothing. So it has to go in the appropriate part. So let's continue to talk about our belt drive here. So we have a modular engine fluid pump. This is used for pumping different things like coolant especially. So we can put that on there right there like so. If we look at this, we take a pipe, and we stick it on there, you'll see fluid in and fluid out. If it tells us which direction it has to go in and out, we have to make sure we respect that, or else it's not going to flow properly. Sometimes you'll get fluid A, fluid B. That means it can go on either side. It doesn't matter. But when it says in and out, it has to go in that direction. Now, we're going to be putting it through a radiator, so it really doesn't matter. But there are other applications. For example, if we're going to pump air into our cylinders to supercharge it, we will want to make sure that we're taking the air in from here and blowing into the engine from here. But we're going to use this for cooling. All right, the other side here, we're going to use an alternator. All right, so we have a modular engine alternator. And we'll, again, make sure that it's on there correctly with the belt aligned. Now let's go ahead and we'll look at some of these nodes. We'll go to logic. This is a Boolean on-off. On-off is also known as Boolean. That's a starter. So we don't want to leave our starter on. I see time and time again new players asking, my engine's making a clicking noise and my battery's dying very quickly. You don't leave your starter on the whole time. What you want to do is come up with some sort of microcontroller, some sort of logic that is going to shut your starter off once the engine is on. That's how it works IRL. For example, in game, the engine will start and have sustained momentum at 2 RPS or greater. So as long as the engine gets above 2, we no longer need that starter. So we can shut the starter off and then we're not wasting battery anymore. On the alternator here, you see we have clutch pressure. So what that does is effectively what it's doing is this belt's going to turn and we're going to decide how much pressure we want so that it transfers more or less energy. Now, we don't get anything for free. If we use a 1 value, which is the max number on this, it's going to be producing as much electricity as possible, but it's going to be putting load in the engine. So for example, let's say that we don't need all that electricity. Let's say we're barely using electricity. We might need a small number like 0.1 clutch will give us plenty of electricity. That allows the other amount of the engine power to remain for actually powering our vehicle. So that's important to know. Over here we have the same thing, clutch pressure. Now, when we're cooling, for example, it's best to get your engine warmed up, just like in real life. So I tend to like to run my engines a little over 100 degrees. And so often I won't even turn my cooling on until it gets over 100 degrees. So there's a couple ways that you can do this. You could feed it a 1 and it will turn on the pump 100%. And then as soon as it gets below 100 again, it will shut the pump off. Now, the more advanced way you can do this is you can set it up with a PID where it will automatically vary how much pressure is going to either the pump or the alternator, and it will give us just as much pressure as we need to maintain the battery, and it will give us just as much pump as we need in order to maintain the temperature. So we'll go through all that. So the nice thing about modular engines are that they are modular. So we can click on this and we can add more cylinders. We can add as many as we want. This is very helpful because, for example, let's say that we had a simple 1 cylinder. So we'll grab a piston, 1x1 piston, and we'll stick it on top. And you find out that this engine is not big enough for you. Okay, not a big deal. Click on that, bing, go, bingo. And now you've doubled your engine power. You want to, still not powerful enough? Now we've tripled it. And now we've quadrupled our engine power. So this is very nice and very easy. It's also, the size of these are pretty compact. If we were to take a small engine, one of the old prefabs, as you can see, it takes up a lot of space. This one here, as you notice, I have a 3x2 on the front. But other than that, it is pretty thin and compact in the back. And so this allows you to fit engines in where you may not be able to with prefabs. The other thing, too, is if this engine here, this small, is not powerful enough, well, guess what? You need all of this engine. You need all that space to double the power. With this, we can come up with creative ways to double the power. Say we want to double the power of this modular engine. Power is now doubled. And as you can see, the space of it is much more compact. Now, they are more complex, but I think these are better in almost every way. So we're just going to make a little 2-cylinder engine. All right, so next thing we'll go back to mod for modular, and we need a clutch. Now, a lot of people don't know what a clutch is. Essentially, what's happening is we'll bring up a GIF here, and we'll take a look at it. All right, so here's a little GIF of a clutch. And so here's our engine. As you can see, it's turning this shaft, and it is turning this disc here. And then what we have is we have our clutch pedal. So as we let go of the clutch pedal, in a car, when you push the pedal down, it disengages the engine from the transmission. And the same thing's going on in this diagram. As you let the foot off of the pedal, this conical disc will push into this other disc here. You'll notice it's red here. That is usually some sort of abrasive material, so think sandpaper. And so you imagine if you have your hand and you're waving your left hand back and forth, and then you go and you barely put your right hand on it, but you keep moving your left hand, it's going to slip past and it's going to slip. That's what happens in a clutch. That's your friction zone, and you get slipping. Now, if you push your hands together, as you move your left, it's going to move your right. The friction is causing it to move, in this case, whatever we're turning in the back. The output shaft, which could be going to a propeller, or in this case, we're going to build a car, so it would be the wheels. And so that's what a clutch is. So in the case of this, and then interpreting it in the game, when this is all the way out, that is a 0. When it's all the way in, that's a 1. And you want a gentle application of your clutch. You don't want to turn it on and off. This can do things like break components of your car IRL. This can cause you to stall your engine. You need to have enough torque to keep the engine running, and you need enough torque in order to do the work that you're trying to do. So for example, when you come to a stoplight in a manual car, you need to push the clutch pedal in to disengage the engine from the wheels, because if you're stopped, the wheels are now stopped. And so what would happen is if you didn't put your clutch pedal in to release the clutch plates, you would cause the engine to stall. The brakes on the tires and the friction from the ground would actually stop the engine. And so we can't have that. We need the engine turning in order to make compression and keep the engine going. All right, so now that we know what a clutch is, that's in there. We'll look at logic here, and as you can see, we feed it a number, 0 to 1. Now, there are some glitches. I'm not going to go into that. Really, what you should have is when you're fully going, your clutch should be all the way out. Now, this doesn't happen in game, but it happens in real life. For example, if you left your clutch a little bit in, you'd be slipping your clutch plates, and imagine if you're rubbing a couple pieces of sandpaper together for a long time. Eventually, you're going to rub off all the sand, and there's not going to be any friction anymore. It's going to be just two pieces of paper rubbing on each other. We don't have to worry about that in game. The clutches can't break, but ideally you want this all the way in. So we'll go over auto clutches as well. All right, so let's go over some more parts. So we need to have an air manifold. All right, so we're going to go ahead and we'll stick this air manifold on here. Now we need to talk about how these pass information and how they pass fuel and how they pass air through one another and how they pass exhaust. As long as these pistons are touching with this face here, the 4 circles and the square, we can put the air manifold on this cylinder. The air will go through this cylinder, and it will also pass the air to any other connected cylinder. So this one, you'll see some of the very old tutorials when these first came out. People would tell you to go and put multiples of these. You don't want that. You want one air, one fuel. Now, there are some cases where people are trying to stretch the systems, and they'll do that, but we don't want to do that. Now, say, for example, you wanted to make a V4 like this, all right? If you put your air manifold on like this, the air is going to go through, it's going to pass through here, it's going to go into this cylinder, and it will go into this cylinder, but it has no way to get to these cylinders. So these will get air, but this will not. So that's where these manifold pieces come in. If you wanted to make it a 4, you'd have to do something like this so that there's a path for this to travel. So it travels through the air manifold, through this cylinder, through this cylinder, through this manifold piece, and then attach. So you have to attach all those. All right, so keep that in mind. You can go all the way around. You can do a radial if you'd like. We're just going to do an inline like this, but you do have to add those manifold pieces if you want those to essentially pass air, fuel, exhaust through one another. All right, so let's start here, and we'll actually start with our cooling really quickly. So I'm just going to use this pump. And I'm going to put a cooling manifold on there. If we turn around, as you can see, it has that face. So, for example, this will place there because we can use it for decoration, but that will not do anything. This has the square and 4 circles. It must go on a square and 4 circles. You do not need tanks. There are some very minor cases where you may need tanks. For the vast majority of time, you do not need, nor do you want, water tanks. It's actually going to slow down flow rates. You don't want that. You'll see some old tutorials that do that. That's why I'm making a fresh tutorial here, is to alleviate some of those issues. So let's go ahead, and we're just going to take a radiator. The most efficient radiators we have are these electrics. You can use these if you want. I still use this one a lot because I like the look of it, but you can use these electrics. There's 3x3s, there are 5x5s of these electric radiators. These allow you to turn the fan on and off and also pump through. This one does not have a fan, so this one is just passive radiation. And so we'll go ahead, we'll just grab a 3x3 here, and we'll stick it somewhere on here. We'll stick it on the front, and we'll go like that. And now we have a radiator on the front of our engine. That tends to be where they'd be IRL. Now, if we remember, this is fluid out, that's fluid in. It doesn't really matter in this case. We're just doing a loop. All right, so we're going to loop this. So we're going to go up like this, and we're going to go in. Now, if you look at this one, it says fluid A. That means we can put it on either side. It does not matter. If it says A and B, it doesn't matter. If it says in and out, we have to make sure that the in and outs go to the correct side. One thing you want to not do is add a bunch of T-pieces. If you'll see people tee off their radiators like this, the T-pieces will slow down your flow, which will decrease your cooling. So we don't want to do that. These elbows are pretty reasonable. I have a cooling tutorial you can go ahead and watch. If you watch the cooling tutorial, you'll see some of the best systems. The shorter the run of your pipes, the more efficient it is going to be. So keep that in mind. The shorter the run. So for example, if I wanted this really short, we could try to put it so on top so it wasn't running too far. But the fewer the pipes you have, the better the flow rates you're going to get, the better the cooling you're going to have. All right, so next thing we're going to do is we're going to get ready to put in some of our other parts. So let's go ahead back to mod for modular. We'll grab the modular engine fuel manifold. I'm just going to stick it right here. All right. And I'll show you why I'm sticking some of these things where I'm sticking them. We're going to go ahead and we're going to do supercharging. Supercharging is using the power of the engine to turn something that will then blow air into the cylinders. It allows us to pack more air in. The more air we take in, the more fuel we can burn, the more powerful our engine can be. This will cause more heat. Burning fuel causes heat. So the more that you put in there, the more heat you're going to produce. So we will go into that. All right, so the next thing we want to do here is I'm going to put in a T-piece, and this is going to be for my impeller for my supercharger. Now, you don't have to do this. You can run without a supercharger. The same systems will apply. I like to put them in there. It gives me some extra power, but you don't have to. And I'm going to use one of these small impellers. This is pretty much what I always use. If we look at the impeller here, we'll grab the pipe again. It says fluid out, fluid in. Again, you need to be careful that if we turn it on our side, you'll notice it has a different color. That says RPS. So that's your power, and that's coming from the engine. So we want to turn this, and we want to hook it to the pipe coming out of the back of the engine. All right. Now, you can do it like this. So this is one engine build you could do. You can have it go direct drive clutch here. That's fine. Things like race cars, stuff like that, you tend to want to do this. The other option you have here is a flywheel, which is a flyweight. And if we look at the shapes on this, as you can see, it has the crankshaft pieces, so it has to go in the crankshaft. Now, we could go like this. Now, what is a flywheel? What does it do? A flywheel is all about conservation of energy. An object in motion wants to stay in motion. An object at rest wants to stay at rest. So this is just a big weight. And so what it's doing is it's adding mass to the crankshaft so that if the engine is turning, say, at 10 RPS, now we're moving a big, heavy weight that turns at 10 RPS. If we look at its weight, it weighs 100 mass. So that's a lot of mass. If we look at just the crankshaft weighs 1. We have 2 crankshafts, so we look at our pistons, they weigh 1. So we have a weight of 4. So it doesn't really work like this, but it would work like this IRL is the parts are moving, and so that's like, a mass of 4 moving. It's not that much mass. Well, now if we add the flywheel, it's 104 mass moving. And so therefore, our engine is not going to want to change RPS very quickly. This is not good for a race car, but big flywheels are often on things like tractor trailers. They're on things like trains or generation system for diesel electric trains. They would be on boats to help keep the propellers moving. They're less likely to have shocks in the system. Now, we're just going to not bother with the flywheel now. We don't need it. But keep that in mind. It's going to take you longer to start because that object at rest wants to stay at rest. It doesn't want to start moving. And it's going to take you longer to get the engine to slow down because that object in motion wants to continue to stay in motion. All right, so keep that in mind. All right, so I'm actually just going to turn this a little bit here. We'll cut it and we'll rotate it like so. All right, and let's go ahead and let's look at what we have on here for nodes. So we have fluid out and we have fluid in. So what we're going to do here is I'm just going to do mod for modular. And we'll go ahead and we'll grab modular engine air manifold. And we'll just go ahead and we can stick it anywhere, but let's stick it right here. And so we want to go air out. That air is going to come out from the impeller and it's going to go into the air manifold. So that is going to supercharge our engine. That is blowing air into our cylinder, which allows us to, say, get a 1.5 air volume, and that allows us to get a 0.75 fuel, where if we didn't do this, we wouldn't be able to get as much fuel packed in, and we don't have as much power. All right, so then what we'll do is we'll add an air. We can put whatever we want on here. We can put a fluid port, any of these. We can put on an air filter. I'm going to stick an air filter on there for now, and we'll do that in the fluid in. So you got to make sure you're doing fluid in and fluid out correctly. All right, so the last thing we need to make this engine run is, if we look at do mod for modular again, is exhaust. right? So we can use a corner or a straight piece. They're the same. Now, I see a lot of new players doing this. They'll go like this, and they'll go ahead, they'll grab the exhaust piece, and they will say, they'll grab this exhaust piece, the tip, and they'll put it on like that, and they'll say, my engine isn't running. Now, you have to look at the parts again. So let's look at these parts, and like pieces have to be unlike pieces. This one here, as you notice, has that octagon. Well, that goes to a pipe. All right. The other side of this exhaust is the square with 4 holes. So as you notice, this one has a square with 4 holes. Well, a square with 4 holes does not connect to the octagon. So you can't do this. You want one of those parts. So what we'll do is we'll just put a corner one on for now. You want one of these. Now, you can put multiple exhaust on there. You want to do dual exhaust, you can do that. That's fine. But you only want to put one of those. And then because the piece turns into octagons, then you want to start putting pipe. All right, so well, let's move this on the other side so we can put our fuel on there a little bit easier. So let's go like that. And we'll just do that so I can plumb the fuel up. All right, so pretty simple there. Now, one thing you might want to put on here is a catalytic converter. So we type in cat for catalytic converter. There's a catalytic converter. It reduces particles from exhaust. Catalytic converter that removes fumes and decreases the number of exhaust particles emitted from an exhaust. So IRL catalytic converters, they use often platinum as a catalyst, and they convert the exhaust gases into less harmful substances that are better for people to breathe and the environment. And so if you notice, it has exhaust in and exhaust out. This one's directional. You have to be careful. So what you want to do is when you take your cat, you want to press it like that, and you'll notice that that will always orient it so that the exhaust out is this way. If you put it backwards, you're going to get nothing. All right, we'll go to exhaust, and we'll just grab this tip. Now, you don't need to use this fluid exhaust. For example, you can use a bunch of stuff. You could use a ram. So sometimes you see people put this. Any of these ports that allows the air to come out, you can use. So we'll just, for the sake of making it simple, we'll use an exhaust here. So you can use that exhaust, but you do not have to if you don't like the look of it or you want to hide it somewhere else. So pretty simple there. All right, we now have the componentry required to make this engine run. So what we need to do next is we need to actually make a microcontroller, and we need to program that up to make it run. Now, I've changed the way I've done this many times. I've refined it. One of the reasons I'm making a fresh video is, there are new practices that I find to be easier, better to understand, and I always like to make my videos a little bit easier for you to understand. So go ahead and we'll take a driver's seat. We're going to control it from the driver's seat. All right, and we'll go ahead and let's look at the driver's seat here. We have ADWS, left, right, up, down, trigger, all of our hotkeys. So right here for 6, we're going to make this start. All right, and we can do a couple things. One thing I'll do is I'll do an auto restart for you. If you don't tune your engine properly, or if you slam on the brakes sometimes you will stall. And with an auto restart, it will automatically restart the engine. So we'll go ahead and we'll make this a toggle start. All right. So what we'll do next here is we need to get a microcontroller. So I have one I call blank. You can come up here, click on microcontroller, start building. I just have one that I essentially named blank, and I saved it. You can do it either way. So I just have one called blank that when I call it up, it gives me a 1-block blank microcontroller. So I'm going to go ahead and stick it here for now. And I'll start expanding this. So this will be the Stormworks Basics Mod Engine Tutorial. All right, so this is going to be a series I'm going to go through. I like to improve these every once in a while. And so we'll go ahead and we'll make this big, update that, and we'll take a look at it here. Make sure it didn't erase anything. It did not. So perfect. All right, so we're going to start with our composites. Composites are one node that allows a lot of information to pass through. These are very useful. The devs have been doing this more and more, and I think it's great because it allows us to pass tons of information in one node, saves us a lot of space. So we're going to start with this, and the first composite node we're going to input is our seat. All right. The second composite node we're going to input in is going to be a composite input engine. All right, so this is going to be, I'll type it all the way out so you guys can follow a little bit better. And so this is going to give us engine information. It gives us 3 values. It gives us how much air is going into our engine, how much fuel is going into our engine, and the temperature of our engine. That's why, if you remember when I was showing all the parts here, I said we really don't need this modular engine temperature sensor. We can get that temperature from the composite here. So I almost never use that one. All right, so let's go back in here and let's continue to work and build. All right, so we'll go back to logic and we're going to add our next thing. So we're going to do a number input, and this is going to be RPS. So our crankshaft will report to us the RPS, the revolutions per second. And we can utilize that to control our engine and know how fast we're going. And a tachometer on your car is what will show this IRL. And we can do that in game as well. So next thing we'll do is we'll do a number output. Now, the first one here we're going to do is air manifold. And this is going to go out to our air manifold and tell it how much air to allow into our engine. All right, add another one here. This will be fuel manifold. All right, number input, fuel manifold. All right, this is going to go out to our fuel manifold, tell our fuel manifold, it's going to be an output, how much fuel to go. Next one here, we want a number output. This is going to go to our clutch. This is going to give us our clutch value to allow the power to pass from our engine into the, say, wheels, propeller, whatever we want. All right, so next thing we're going to do here is we need to do an on-off. It's going to be an output. That's going to go to the starter. All right. And we'll go ahead, we'll add another node here. This will be a number output. This will go to our coolant pump. Eventually, I'll be able to spell. That's our coolant pump there. That will go to the clutch on our pump, and it will vary how much our pump is pumping in order to maintain the temperature we would like. Next thing we'll do here is we'll add another one, number output. This is going to go to our alternator. All right, remember, our alternator is a small generator that will recharge our battery. So as we turn on lights, as we use things like different elements in the game, like a horn or whatnot that might use some electricity, it's going to then recuperate the electricity. It will use the belt to drive the generator and produce electricity. You really, especially in cars and trucks, you really don't need much more than an alternator or two, depending upon your operation. Some people are really over-generating because they're, not really producing the electricity they need. All right, so in this case, we're using one of those electric radiators, and because of that, we also need to have a radiator. And that will control the radiator fan, so we'll have that on as well. So let's go ahead in here. We'll start working. So first thing I like to do is I type in text eventually, and here's property text. I like to do this just because our nodes here are all going to spawn in one place, and so I will write in spawn. And that way we know where they're going to spawn, so it's easy to find them. You'll see people who will just build right where their spawn is, and now they're spawning stuff right in the middle of their build, their logic build here, and then you can't find where your new nodes spawn in. If you do it this way, this will allow you to easily find all of your nodes. So what we'll do is we'll then move down so that whenever we make a new node, it spawns up here, and that makes it super easy to find all of our nodes. All right, so I'm going to start to put these out. So we'll start getting them set up here. And we'll put all our inputs on one side, outputs in the other. Everybody has their own way of doing this. The cleaner, I think, the better. It's easier to find. So we'll go ahead, and I've got them stacked up. So the first thing we need to do is we need to control our engine. You'll see a lot of people who are trying to do this very basically. You'll notice that after the pressure update, a bunch of people's modular engines stop working. Some people, every one of their modular engines stopped working. None of mine stopped working at any point. Because the way I do it, it always will vary the fuel to the air. So any change they make in pressure, either something you do or something that the devs do, this system will automatically change your air and your fuel to maintain the proper stoichiometry. So it is better to learn it the right way. This will really help out a lot. All right, so let's update this really quick, and let's look at our seat. Now, I use WS to move my car. So if we look at the composite node, so click on logic composite, and then we'll hover over the driver's seat. You'll notice that we have outputs the axes, hotkeys, and occupied data from the seat. On off 1 goes 1 to 6. On off 31 is trigger. On off 32 is occupied. Value 1 is AD, which we're going to use for steering. Value 2 is WS. Value 3 is left right. Value 4 is up down. Value 9 and 10 are look X and Y. So we're going to use the WS key to go forward on our car. That's going to be our accelerator brake. And so if you notice there, it says value 2. So we're going to go ahead, we'll grab this node, and we'll plug it right into seat. All right, we'll click on this, and so we're going to use value 2. So we'll go on, you can put all these in your bar if you need to. Click on that, search for them. I'll tell you what they're called. So first thing we're going to do is composite read number. We're going to click that. You'll notice it has 2 nodes. It has a composite, and it has a number. We're going to go in here. I'm going to change it to channel 2. Remember, channel 2 is our WS. All right. Now, what we're going to do is, as we press down the accelerator pedal, of course, we want to go faster. As we press the S key, we're going to want to brake. So this here is going to be our WS for acceleration. So the next thing I like to do is I go to this function here. This is the XYZ function. If you go and search for that function, you have a couple here. You'll notice we have an XYZ, a X through D, and we have a 1 of them. So I use the 3 quite often here. And so the first thing we're going to do here is we're going to plug in 2, and we're going to plug it into the X. And next thing we're going to do is we're going to make a formula. Now, this is kind of the new way I do it. If you watch some of my older tutorials, I did it a little bit differently. This makes it much more configurable. It makes it easier for you to change things like your idle, your max RPS. If you want to go a little faster, you can very easily change your maximum RPS. So first thing we're going to do here is if you go into add-on and you come down here, we have clamp. Now, what does a clamp do? It keeps the X value within Y and Z. So, for example, let's say that you want your idle to be 3.5. That would be your bottom level, your bottom number. That would be your Y. And you want to say you want your maximum RPS to be 20. That would be your Z. And so what we're going to do here is we're going to use a clamp, and we're going to put that in. So let's go ahead and we'll type clamp. And then we're going to put parentheses. So if you ever have an issue with this where you forget, just come back and look. It should look like this. Clamp, parentheses, X, comma, Y, comma, Z, parentheses. That's what it should look like. All right, so here we have our clamp. And now inside of here, we're going to go X times Z, comma, Y, comma, Z. And I'll tell you why I do it this way. What this is going to do is it's going to take your X, which is your 2. Now, your 2 value can go from your WS from -1, which is going to be maximum brakes for us, and it could go up to a maximum value of +1. So if we take our 1, which is our maximum, our foot is all the way down on the floor, and we multiply it by our maximum RPS, for example, let's say that's 20 RPS, when we press our accelerator pedal all the way down, we ask the PID to give us the maximum RPS that we want, which in this case will be 20 if we put that number in. If we change it to 15, it will then change us to 15. So that's how we're going to do that. And next thing I'll do is I like using these now property numbers. And I'll show you why in a minute. So what we'll do here is we'll do engine idle. So this will be the idle your engine runs at. Now you want your engine to idle above 2 RPS because if the engine goes below 2 RPS, it no longer makes enough compression to keep the engine running. And so the engine will shut off. And so in this case, I'm just going to do 3.5. Different engines, I like to run at different stuff, but this allows you to easily change it. So we'll do engine idle 3.5. That goes to our Y. Again, X times our max number, Y is our minimum, and then we have our maximum, our max RPS allowable. So what this means is when we let our foot completely off of the W key, it's still going to tell our engine, hey, keep idling at 3.5. It's going to make sure our engine doesn't shut down. If you don't do this, when you take your finger off the W key, the engine's going to shut off. It's going to go too low, engine's going to stall, and it's going to shut off. So you need to set an idle. All right, we'll copy the property text there, and we'll stick it right here, and we'll plug that into Z. This is going to be your max RPS. All right, so maximum RPS. And in this case, we'll make it 15. All right, so this formula here is pretty simple, and it's going to have the 2 key, which goes up to a 1, multiplied by our maximum RPS. So if we pressed it in, let's say we press our W key halfway in, so it's at 0.5. It's going to be 0.5 times 15. That's going to ask our engine to rotate at 7.5 RPS. A little bit more, it's going to go a little more, and it can go all the way up to a maximum, in this case, of 15. All right, now I'll update this and I'll show you why. Now, when we click on our microcontroller, you'll notice we get engine idle, what we typed in there, we get max RPS and spawns there just because we're using that as a spawn tab. So what this allows me to do is, let's say my engine is we're not going as fast as I like. All I have to do is click on this, press 20. I don't have to go in the microcontroller and search for it. This is going to be helpful for tuning in our engine. We can change it right there. If we change it to 20 and we go into the microcontroller, you notice, bingo, there it is, changed to 20. We change it to 15 there. We look, 15. So that allows us not to have to go into the microcontroller. Makes it a little bit easier to edit the engine. All right, so that is all set up there. All right, so next thing we need is a PID. PID is one of the most important and useful tools in the game, and we have two of them. I almost never use this one anymore. We'll take a look at it really quickly. This allows us to put our proportional gain, our integral, and a derivative in here. I don't like to use that one because we can't really plug anything into it. For example, you might be driving and you want to change your p-value on the move, and this allows you to say take a keypad and plug in a value while you're operating. So, for example, you're running your car and the engine is not ever reaching where you'd like it to. You can increase that p-value while you're actually driving, and so I like to use this advanced PID. We'll take this value here, and we're going to go and we're going to put it into our set point. What our set point is doing is it is setting the value that we want. It's saying, hey man, I want you to go 3.5 RPS. The PID then says, okay, where am I currently at? That's your process variable. Your process variable is where the engine is at. So we're going to use the RPS here. So what we'll do here is we'll go over here to RPS, all right, and we'll plug the RPS into the process variable. So, for example, we're going to say, hey, I just turned the engine on. I want you to idle at 3.5. So we're going to tell the PID, hey, I want 3.5. It is going to look at the RPS. The RPS say right now is at 2, and it's going to say, okay, that is less than what he's asking for. Therefore, I need to increase the number in order to make the engine rev up and give him what he wants. All right, so that is going to be our RPS value there. All right, so the next value here is a property number. Now, there's a bunch of ways to do PIDs. There's a lot of different ideas people have, and so we're going to do p-value engine. I do p-PIDs. Now, most of the PID value, the PID information I've learned is from my own research. You have p-PIDs, which just run off the p-value, the proportional gain. You have pi-PIDs, which do proportional and integral gain. You have PD-PIDs, which just do proportional and derivative gain. Then you have PID-PIDs, which will run proportional, integral, and derivative. Now, there are 20 different ways to do anything in this game. This is the way I do it. I have hundreds of vehicles. They all work very well. None of it broke during the pressure update. They're working quite well. This is a method that works well for me. There are going to be more refined ways to do it, sure. But you do need to understand this. Some people are trying to get their stuff to work 100% within 10 decimal places accuracy. In real life, you do not have this. I was a tractor-trailer driver. I have, a million miles driving tractor-trailer. There has never been a tractor-trailer that is within 0.00001 of the value that you're asking of it. You could have a little bit of dirt on the accelerator pedal, and it's going to produce more of a variability than that. You do not need ultra, ultra, ultra precision. There are things like, for example, autopilots in game. You may want more precision. This, you do not need that. I know a number that works for me. I'm going to use 0.18. This does change from time to time. If I put on a flywheel, if I have a bigger engine, if I'm using a 3x3, I might use a different value. But that's a good starting value. I'm going to work with 0.18. That works for me. We're going to start there. I don't bother with integral. I don't bother with derivative. There are some very small fringe cases I find integral is necessary. Derivative I'll use for things like stability systems, autopilots. For my engines, I just find P is enough. I get within a couple RPS of where I want it to be. The way the P is essentially working is if your P value is too low, it will never get to the value that you're asking of it. If it's too high, it will overshoot, then undershoot, then overshoot, then undershoot, and it will oscillate, go over, under, over, under, over, under, over, under. And so I tend to use just the P value, and I run it a little bit low so that if we ask 15, we might get around 13.5. That works fine for an engine. You don't need ultra precision with this. All right, so we're going to go ahead and we're going to go with that. All right, so the next thing we're going to do is we're going to bring up the stoichiometry equation. I will copy that, bring it in, and I will show it to you. All right, so I copied in the stoichiometry equation. This I got off somebody else, and I've been using this for a long time. I do forget who put it out there, but essentially, if we look at the first thing here, we have composite read 1, 2, and 3. This is air, fuel, and temperature. Using air, fuel, and temperature in order to get the correct stoichiometry. Stoichiometry being the Essentially, for our cases, it's going to be the air-fuel mixture that allows our engine to run at the setting that we are putting it at. So those go in here, and then they are read out, and we'll go into here and we get a clamp. We have 1 minus y, 0.11. We don't really need to worry about this too much. You can copy this. This works well. This is our AFR. Our desired air-fuel ratio is 0.2. You can change this. This is where you would change it, is right here. And so this works well. I put this on everything. Again, when the pressurization update came out, all of my engines were working because it will automatically change air and fuel, and so I didn't have anything break. So that is this is a good system to run with. So we'll take our engine composite and we'll plumb it into 1, 2, and 3. So again, this is going to give us air, fuel, and temperature, and so that's going to automatically change the values of the engine based on that, and that will keep our engine running at a 0.2 where we'd like it. Next thing we want to do is we want to take our PID and we want to plug it in here. I put a little note up top that says X equals throttle from PID, so we're going to go here and we're going to go there, and so this is going to feed this through, and this is going to give us our air and our fuel ratios that we need. So then we'll come down here and we'll grab air manifold, fuel manifold, and these will go up here. Now, there are simpler ways to do this. I'm going over the better way to do it. I'll quickly go over the simple way to do it. I recommend the better way to do it. You can come in here and you can feed a number directly to the air manifold, and you can feed a number to the fuel manifold for 0.5. If you wanted, give yourself half the fuel you're giving air, but you cannot supercharge. You cannot use a scoop. If you have a pump on your engine, anytime you change the air, the fuel is not automatically going to change. This will allow, through these equations, for the fuel to automatically match to where it should be for the air-fuel ratio and give you an engine that will run in any condition. You are going faster with a scoop, the fuel will automatically adjust. If you supercharge, the fuel will automatically adjust. All of these things are beneficial. So I highly recommend just go to this. Don't do the simpler way. This is the better and correct way to do it. This is why none of my stuff broke during the pressurization update, is because this all handles it for you. And so you can just copy this. This will be on the workshop, and it will just work. So that is good. So the next thing we need to do is we need to turn on our PID. This will activate our PID. Now, when I went in the seat, let's go update this. We'll click on the seat. If we look at 6, we have start, toggle. All right. And so this is gonna, we'll do start/stop. So this will start your engine, it will stop your engine. So it'll start your engine and keep it running when it's toggled on, and it will stop it when it's toggled off. All right, so that's what we want there. And this is hotkey 6. All right, you can put it wherever you want. You want to put it on a key from the engine, you can do that, but we're just gonna do it off the seat. And so then what we need to do is we need to go here, composite read on off. We'll go ahead, we'll grab that from the seat, and this will plug directly into the PID. And so this here will allow us to, when the 6 key is on, when we turn our engine, it will turn on the PID. When we shut 6 off, what's going to happen is the PID's going to go off, which will read a 0 value to the engine, and that will starve our engine of air and fuel, and then our engine can no longer run. It will shut our engine off. So that's why we're doing that. All right. So the next thing we need to do is we need to start our engine. So we're going to grab starter, and we're going to go through some conditions. This is going to have auto restart. Often you will, if you don't tune your engine perfectly, when you slam on the brakes, you might stall the engine. If the clutch does not zero fast enough, you'll stall your engine. There are a bunch of ways you can stall your engine. This will automatically try to restart your engine. So if you stall, it just auto restarts your engine. We're going to start with that. That's, if you want to do it differently, you can, but this will automatically restart our engine. This just makes it especially easier for new players. All right, so when we want to start our engine, there are 2 conditions we want. So we're going to change this. I forgot to change it to 6. Again, this should be 6 because that's what we put on our seat. There are 2 conditions we want to have the starter go. 1, we want actually the engine to run. So we want 6 to be on, and we want to have our RPS be less than, and I usually do 2.5. Once the engine gets above 2, the engine will be self-sufficient, will run. I do 2.5. That just gives me a little bit of extra speed on the engine so that it will not stall right away. It keeps it, it overshoots it a little bit and keeps it going. So what we're going to do is we're going to start with an AND. So type in AND right there. And we'll do this. So 6 and then we're going to set our second condition here. So I just talked about what the second condition is. When the engine is less than, in this case, I'm going to run 2.5. 2 is what we required for the engine to be running and self-sufficient. We're going to do 2.5 so that we have that little extra bit of leeway in there. So what we want to do is do a less than. All right. And we're going to go ahead and we're going to hook our RPS in there. I'm going to punch that in like so. And so if our RPS is less than, and then we're going to put that in. So if our 6 key is on and our RPS is less than, in this case, we'll do a property number again. This will be starter cutout. All right, so what the cutout means is the starter will stop going once we hit this RPS value. So we're going to put in 2.5. We require 2, a little bit of an overshoot. So that goes in there. So if our RPS is less than 2.5 and we want to start, it will start. And so what will happen is as soon as the engine gets over 2.5, which we're telling it we want it to idle at 3, it will shut the starter off. If we go below 2.5, the starter will come on to keep the engine running. As soon as we shut off 6, the starter will no longer come on again. So those are our conditions for our starter. Pretty simple, and that's all plugged in and ready to go. Next thing we'll do is clutch, and so this is going to be an auto clutch. Now, I have a lot of experience driving manual vehicles. Like I said, I was a tractor-trailer driver. You know, it's one of the most complicated transmissions you can have. You know, you have 10 to 18 speeds, and you have to manually rev match all these other things. So a lot of the way I run my clutch is how I would do it IRL. I find this system to work very, very well. It takes in a lot of conditions. For example, there are conditions IRL. Let's say you have a really heavy trailer on a tractor trailer and you're going up a hill. You're going to have to rev up higher and you're going to have to feather the clutch. That's you putting the clutch pedal in and out to make sure you don't stall the truck. And so this will automatically do all of that for you. It's a pretty simple system here. So we're going to take our clutch and I'm going to get working on this. And so I like to use an up-down counter. This is a number that works well for me. It doesn't work for every build. You do have to tune this. For example, if you have a very tiny engine, you may need to rev up very high in the RPM range, and you might have to very slowly release the clutch. This happens in real life. For example, again, heavy trailer trying to go up a hill with too small of an engine, you may need to rev up very high and slowly let out the clutch. This all happens in real life. Professional drivers do this all the time. This system helps emulate that. It will automatically put the clutch in and take it out as necessary to keep you moving. So we're going to go ahead here. The increment is 0.005. This will change. There are certain situations where you can put the clutch in faster. Certain situations where you want to have the clutch go in slower. If you have a small engine and a heavy vehicle, you might want that number to be 0.001. If it's a much more powerful vehicle, an overpowered vehicle, you might be able to get away with 0.01. But this is a number that works for me. I put it in most of my builds. So 0.005. Reset value 0, 0 is the clutch completely disengaged. We're going to enable the clamp 0 to 1. All right, 1 is maximum clutch. Ideally, you want your clutch at 1. There are ways to glitch. I don't recommend it. The best thing to do is when you're going down the road, your clutch should be all the way released. It should be at 1. So in real life, you don't want your foot in the clutch as you're driving down the street. You're going to wear out your clutch. You want that clutch passing as much power through to the wheels as possible. All right, so now we need to come up with the conditions. When do we want to increase this value, which causes the power to pass through the clutch to our wheels, and when do you want to decrease it? And then when do we want it to completely zero the clutch out and make sure that the engine and the transmission are detached from one another, for example, when you're stopped at a stoplight. So the first condition is when do we want to engage the clutch? Well, the first thing is when I want to go forward. So this is saying when I want to go forward. My foot going down, my finger pressing the W key is when I want to go forward. So first thing we'll do is greater than. All right, so when my W key is greater than, so my 2, my W key, when my W key is greater than 0. If you don't put a number in, it's 0. So what this is doing is when I'm asking to go forward, that's what's going to happen. All right, the next value is when we have enough torque to go forward. All right, now, torque is the correct terminology. Torque is the correct, thing that we would want. The way that the game reads out torque is not correct, so I'm not talking about the torque gauge, I'm talking about power. And in this case, really in game, we're reading it out as RPS. So when the RPS is greater than a certain value, now this number will change. You will have to tune this in yourself to your own vehicle. If you have a light car that's just hauling you and the car itself, you don't need that much torque. You don't need that much RPS. And so you can have a smaller number. If you have a big truck that's hauling a huge heavy trailer, you may want a larger number. All right. And so we're going to go ahead here for a property number. And this one will tune in. So we'll plug this in there. Do clutch engagement RPS. So I'm trying to make these titles so you know what they're all about. So this is the minimum RPS value that we want the clutch to start engaging at. And so in this case, 3.5 is our idle. And so we'll do if this is greater than 3.5. So in this case, if we're asking to go forward, so if our W key is pressed down, and the clutch and the RPS is greater than 3.5, we're making enough power to go forward, that's when we want to start increasing our clutch and putting our clutch in. And so we're going to go ahead and we're going to take an and I'm going to plumb the and in here. So we're going to go ahead and we'll do if the W key is greater than 0, and if the RPS is greater than 3.5, we want to increase the up-down counter. Very simple for when we want to decrease it. If either of those conditions is not met, we want to decrease the clutch pressure. We want to start to separate the engine from the wheels in this case, or else we'll stall the engine. So that's a not. So right there, I'm actually going to move this just so you guys can better see it. So that is a not right there. So if this is not happening, if we're not greater than 0, say for example, we're pressing down the S key and we're braking, that will start to decrease the clutch. And if our engine is less than 3.5, we want to decrease the clutch so we don't stall. We need a certain amount of RPS in order to keep the engine running. All right, when do we want to zero this? Well, we want a couple conditions. I have a transmission tutorial. This will plug in with this tutorial. We're going to make this kind of a series. One of these is when we're in neutral. When you're in neutral, you don't want your clutch to apply. So when we're in neutral, we will do that. Now, we're not going to do it right now, so we won't bother plugging that in. But what we'll do is we'll do a quick and. We'll actually do an or. I'm sorry. So we'll do an or. And so you can do this or block. This one's all right. This has 2 conditions. If we need more, we'll do a Boolean. And so we'll leave it as an or because one of these conditions would be if our transmission is in neutral. So you plug your neutral value into here. And the other condition is if your clutch goes below a certain value. You don't want the engine to stall, all right? And so if remember, the starter is going to come in at 2.5, and we're currently idling at 3.5. So what we're going to do is, if this goes below we'll say 2.5, we want to completely zero out our clutch. We want to detach it so we don't stall. And so what we'll do here is we'll go less than. Actually, what we can do is, let's actually do, let's do this. Let's do less than. All right, we'll grab a less than here. Like I said, there's 20 ways to do anything, so, there are other ways to do this, but this is the way I like to do it. So right here, we'll do less than. If the RPS is less than, then what we'll do is grab another property number. Again, I'll show you why we do property numbers. This one here is going to be clutch 0. All right, we're going to want to zero the clutch, in this case, 3.25. So if we have a RPS value less than 3.25, we want to have the clutch disengage from the engine, disengage the wheels from the engine so that we don't stall out our engine. If you were to not put your foot on the pedal in real life, what would happen is the wheels, as you brake at a stoplight, would cause the engine to also stop, and it would stall the engine, and your car stalls. So what you want to do is push your foot down on the pedal IRL, and it will detach them so that the engine does not stop. And that's what this is doing, clutch 0. Now, you will have to tune these. If you put this microcontroller on a big truck, you might need different numbers than if you put it on a small car. This will allow you to tune it and make it behave properly for that vehicle. So that's the setup for our auto clutch. All right, so the next thing we're going to do is coolant pump. We're actually going to do this the simple way. There's 2 ways to do this. One, you could take a PID, and you could plug in the value here, the 3 value. That is our temperature, and you could put that as your process variable. And then what you could do is you could set it to say 100 degrees, and then you could put in a separate p-value. You could turn it on, and it would only give you enough coolant pump to make sure engine stays at 100 degrees, and that would make it so the engine theoretically could stay exactly at 100 degrees. All right, I like 100. It's a good 15 degrees off of the engine burning up, and it is still warm enough we get our some of our best efficiencies. But we're not going to bother with this to be overly complicated right now. We're going to keep it a little on the simple side. And so what we'll very simply do here is we'll do a greater than. So if our temperature, so that again is off our engine composite, number 3 is temperature. If our temperature is greater than, in this case, what we'll do is we'll put it as 100 degrees. So this is coolant pump cut in. So cut in is when it starts, and we're going to do 100 degrees. So at 100 degrees, that's 15 degrees below us burning up. It's going to turn on the coolant pump. And so very simply here, what we're going to do is we'll plug this into a numerical switch box, and we'll do a constant number, and we'll make that a 1. So what this is going to do is this is going to be essentially an on-off switch. It's going to turn on the pump to a max value of 1, which is going to be maximum pumping for when the engine goes over 100. So this is kind of like an on-off switch. What this will do is this will go, say, 100 degrees. It will turn the pump. It might drop down to 98, climb back up to 100, turn it down, go back to 98. It's not as precise as a PID, but it's all we really need. This allows us to quickly hook this in as well. We take our radiator fan. Again, when we go over 100 degrees, radiator fan goes on. We're actually going to add one more step of protection. Your engine will burn up, and it will cause your engine to stop when you go over 100 degrees, you'll catch on fire. And so what we can do is we can put in another condition. So if the temperature is less than 110 degrees and we press the 6 key, this will turn on our engine. If not, it will cause our engine to shut off. So if we ever get too hot, that will automatically shut our engine off. Pretty simple there. All right, next thing is the alternator. All right. And so what we'll do here is we'll set this up with a PID. I'm just going to use a quick value for this, quick number. All right, and then what we'll do here is the 6 is going to turn this PID on. All right. And we'll need to add a node. So we're going to add a node here. We'll add a number. So this will be a number input. This will be battery. All right. And so that's going to be an input. So we'll come in here and we'll look up at our spawn. Again, this is why I put the spawn thing on there. They're very easy to find. So we have the 6 key turning this system on right here. All right. And we're going to have we have our battery here. A battery is going to be our process variable. All right. Our set point is going to be a constant number, and it's going to be 1. So 1 is 100% battery. So I want my battery to always be 100% charged. So we're going to do a 1. All right. And then what we want to do is that goes to our alternator. This is going to automatically control the clutch on our alternator to make sure that it is always producing enough electricity that we can run our battery, or keep our battery charged. So next we're going to do another property name, and this is going to be the alternator p-value. So this is the p-value for the alternator, right? I'm just going to make this a very high number for right now. We can tune this in later. 1,000. This is going to quickly kick this up to make sure that we're producing enough electricity so that we're never discharging, that we're always charging our battery. That can go either side's fine. We'll stick it right there. And so this will automatically, when the engine turns on, when we click our 6 key, it's going to turn on the PID. As our battery drains, the more and the faster our battery is draining, the more and the faster we recharge our battery by increasing the clutch on the alternator. All right, so we're pretty good here. Let's update this. Let's grab a battery. All right, we'll stick this right here. We'll plug everything in. And I'm just going to move this microcontroller here. We can cut it, and we'll paste it behind the seat here. And we're about ready to start here. So this, I know this is about an hour-long tutorial here, but this is going to get you set up so that you can really understand how this is working. This allows you to tune it. You can move this from car to car to car to truck to car to boat, and it will work. All right. And so I do a little bit different on boat. I will go over boats again. I have before. You can watch some tutorials, but I will be making a new one, trying to go through everything over and make it fresh. So I plugged in the engine. composite there. Let's plug in the rest of our nodes. We're going to take an RPS. It doesn't matter. You just need one of these off the crank. That's going to go to RPS. Next, we have the air manifold. That is going to plumb into our air manifold. We have the coolant pump that pumps into our belt-driven coolant pump. Alternator goes over to our alternator. The fuel manifold goes right here to our fuel manifold. The battery is going to plug right in there. The clutch goes right there to our clutch. We have the radiator fan, will go right there, and the starter goes right here. And we're pretty much all plugged in. We need one more thing to make this run, and that is fuel. So just going to grab a quick tank, very small tank of fuel right here. And that's going to go on and plug into the... I had symmetry on, that's why I was doing the red box. That's going to plug in there. Now, one thing you're going to want to add to your tanks now, I'll actually plumb it up so I can show you with the new pressure update. I'm not going to go into the physics of pressurization and everything right now. That'll be a separate video. I'm just going to add a quick T-piece here. I'm going to add a hose anchor. This will allow you to refill your engine. Again, you can build this out how you like it later. And then what we'll do here is I'll add a gas relief valve. Right here, gas relief valve. This allows gases to equalize outside. Grab a fluid port. Right here, I like these new ones. We're going to use the fluid port end, and we're going to plug that in. So what this is going to allow it to do is, if the pressure in this tank is greater than the outside atmosphere being 1, it's going to let the higher pressure leak out to the lower pressure and equalize. So if the atmosphere in here was, say, 2, that will let it equalize with the air pressure. You need to do this or else you're not going to be able to fill your tank. If the air pressure in here was, say, 10, you would not be able to get any fuel in there. You're also not going to reliably necessarily be able to get your fuel to come out if the because you need to replace that fuel volume with something. You need to replace it with air. And so this is kind of a new thing to do, is add that gas valve in there. So really simple. It's going to be T-piece. We want to grab the gas. Gas valve will only let gases come out. So no liquid will leak out. If we put a liquid valve on there, it would just let the fuel leak out. This tank starts as diesel, so we're good to go there. And we should be ready for a start. So let's check everything. We're good. So we're all good to go. So let's start it up. Now we've got a crank going on this engine. So we'll go ahead and we'll press 6. Engine is up and running. We can get out of our seat. We can look at the cylinder here. As you can see, we have an air-fuel ratio of 13.7. Our stoichiometry is 0.2. Remember, that system is automatically changing air and fuel to maintain 0.2. Our efficiency is 99.5, really nice and efficient. And our exhaust is coming out at 100%. We'll go ahead and we'll look at the custom menu here. Infinite fuel is off. I can shut infinite electricity off now that we have the battery plugged in. But you notice infinite fuel is off. All right. If we look at we'll page up and we'll use tooltips. We're at throttle of 0.13. The PID is automatically controlling this to make sure that it is giving us just the right amount of air and is automatically controlling the fuel. This is why none of my systems had any issues with the pressure. It will automatically compensate, and that's what you want. All right, let's add one more thing really quickly here. We'll just add a quick wheel on here, and this will allow us to see the auto clutch work. So we're just going to plug this wheel right on the end there like so. All right, so we just need to make sure the electricity is all plugged in now. So we need our starter to be plugged in, our alternator, and our radiator. So you can plug these in however you like. I generally will plug the alternator in directly to the battery to charge, and the battery can come out to starter and radiator. That's it. Now that infinite electricity is off, we need to plug it all in. So that's plugged in. We'll spawn it. All right, and we'll start up our engine. 6. Engine is up and running. Let's get out of our seat, and we'll take a look at it again. As you can see, the engine has a stoic of 0.2, air-fuel ratio 13.7, 99.5 efficiency, exhaust is good. If you ever have an engine that slowly starts to die, that it tends to be an exhaust problem, so keep that in mind. Often you'll have people that put a catalytic converter backwards. They'll have too long of a pipe. If your pipe is very, very long, you might need a pump, but that's usually something to do with ships with really super long pipes. All right, so we'll go ahead and we'll sit in our seat, and we'll start revving up with W. And there we go. So we have this wheel starting to turn. Now the series is going to continue, and as the series continues, we're going to go ahead and do more stuff. So I'll go ahead and I'll press the S key. I don't have any brakes set up, but the engine's going to go down, and it's going to release the clutch. and this wheel will come to a stop as I press the S key. And so we will go into more of this, but as you can see, press down the W key again, and there goes the wheel. So this is going to be a series, so we'll continue from here. I also have a transmission tutorial. We'll be taking the transmission from the transmission tutorial, plugging it into this engine, and we'll build a car from there. We'll also do some tuning. For example, I will make a car super, super heavy, kind of like a truck, and you'll see how the numbers on that panel have to change. So this will be in the workshop. You guys can go ahead, use this panel. I just ask if you use any part of my builds here that I put in the workshop, just please credit me. You can just say use Captain Cockrell's engine microcontroller, and that was good so people can find it, and I would certainly appreciate that. So I hope you guys found this first part of this tutorial helpful. Again, this will tie in with the transmission tutorial, and this is new for November 15th, 2023. So this is going to be my most up-to-date modular engine tutorial. So I hope you guys found this helpful. Any questions, you can go down to the Discord link below, and you can ask for help in the help section. You can also put any questions you have in this video, but it is much easier to answer in the help section as I can put in some pictures. So thank you guys for watching, and we'll see you in the next one. Bye.